jump right in here. If you got a notebook out, it'd be great for you to take some notes today. Let's these are very good, but we'll get one here. Okay, I'm going to go to the back side here. All right, so here's an example of a problem that they're asking you to, excuse me. So any idea how to start this, or anything jump out at you when you're trying to solve a problem like this one?
To first like try to simplify, see if you can simplify anything.
Yeah, good word choice there. Simplify. You're going to do that by distributing this 3 to both terms in here. So
Okay.
3 times 5x is 15x. 3 times minus 4 is minus 12. And then you drop the parentheses. So simplify can mean a bunch of things. One of them is you're going to distribute, which we just did. The next thing that it could mean is to combine like terms.
Okay.
So let's get caught up here. Why that's taking so
And then
long to upload.
do you take the 5x plus 5 and you just kind of like I don't know what to say, but like
I want your
get rid of
focus to
it?
be on the right hand. I want your focus to be on the right hand side here. You can combine
Okay.
like terms first.
Yeah.
Okay, what do those
5.
combine? Yeah, 5x. Okay, so that becomes 5x. And then we bring the other stuff down.
Okay.
Okay, so now any idea what to do? You kind of were alluding to it in the previous problem.
Yeah, you kind of just like, I don't know how to explain it. You exit out the 5,
You're going to subtract the 5 or the 5x. Sorry, which one?
the 5x.
Okay, yeah, you're going to subtract 5x from both sides. All right, now on the left, they cancel. On the right, they cancel. So is this a true statement?
No.
Or is this question? No, this is not. So this is a no solution problem. And I really did not intend to pick that, but that is the case here. All right.
Cool.
Okay, so
It always
that
has to be like an x equals, right? Like
yes, and it could be, but it's all is a solution. Okay.
Yeah.
Good. Now, that's the solve algebraically, what we just did. Everything that we just did right here is the solve algebraically.
Yeah, this is what we're doing in class. So
have you done the graphing in class?
not really, no. But if there's no solution, do you graph it still? Or no?
Yes. And that's I'm asking because we have to go back to this line right here, which I'm going to grab for you. So this is how we're going to solve by graphing, and I'm going to snip in a graph in a moment here. But if you recall, we got it down to 5x plus 5 equals 5x minus 12. Okay, and what this really is on the left, it's an equation. It's y equals 5x plus 5. And this equation has a slope and a b value.
Yeah.
Do you remember that from earlier in the year? Can you tell me what the slope is? Can you tell me what the b value is from this?
Is this 5x?
So the slope is a number. It does not include the x. It's the number in front of x.
Oh, then it's gonna be 5 and 5 then.
Yes, exactly. Okay. Now, not so helpful because maybe it's not clear which one it is. If we look at the other one, the other side of the equation, what is its slope and what is its b value?
Is the slope 5 and then the b
Yes.
value is 12? Yeah.
Negative 12. Very
Negative
good.
12, sorry.
Okay, so let me snip in a graph and we'll yes, you do graph. We'll talk about what this means in a moment. So when you're graphing, you always start with the b value.
Okay.
And that's along your y-axis there. So I'm going to switch colors. I guess I'll go blue. You put a dot there at the 5. That's that b value.
Okay.
Now the slope is 5. And what that really is it's 5 over 1. It's always rise
Overrun.
overrun. So that means from that blue dot, you're gonna go up 5 and right 1, up 5 and right 1. So
And then don't you do it to -2?
you only need the 2 points to graph it.
Okay, because
But
every time in class when we do it, we kind of do it like also to the negative. But yeah, I know
yeah,
what you mean.
so you have a line that looks something like that. Mine's
Yeah,
not
yeah.
particularly straight, but it's, if I had a ruler, I would do that. Okay, now in the second equation, you start with the b value, which we kind of have to modify here. We'll just call that -12 right
Oh, I
there.
have a question. Is the
Yep,
rise overrun for just everything?
it's always rise over run for the slope.
Okay, so like every time we're graphing, I do rise overrun, right?
Yes, yes, and I'll get into exceptions when we have it. Sorry about that. I said at the wrong time. The the rise over the run we'll get into, yeah. So from that blue dot, I'm sorry, that green dot, the green dot is down here at -12. You always start at the b value. You're going to go up 5 from that -12 and right 1. And I'm literally just counting 1, 2, 3, 4, 5, right 1. Up 1, 2, 3, 4, 5, right 1. Up 1, 2, 3, 4, 5, right 1. 1, 2, 3, 4, 5, and right 1.
Okay.
Now there's a word that we would use to describe these two lines. Give you a chance to guess it if you want. Any idea
They're
how
like parallel.
they're parallel? So parallel lines never intersect. Never.
Okay.
No exceptions. They never intersect. That's why
So
there's no
even
solution.
how it's like -12, you just make like if it's like goes past the sheet,
Yes.
you make your own lines.
Yes. You can get
Okay.
upset at your instructor for not giving you the right, grid, but I think it's great that you're asking these questions. These are the questions that are going to help you to figure out where your
Yeah.
learning gaps are. So please keep them coming.
Okay.
Any questions on that?
I'm just getting it down.
Okay.
Okay, I got it.
All right. So let's look at another question here. We're going to tackle it the same way. We're going to first solve it algebraically, and then we're going to do some graphing for that.
Okay.
So you said this in the previous problem. You said, like the first thing to do is to simplify, and that can mean a couple of things. Again, it's going to mean to distribute. So I want you to distribute this 3 to the 2x and this 3 to the 1, and tell me what the result is. And I know you need a moment to get that written down, but
Here, yeah, let me
if you could give that a try, please, and tell me what you come up with.
okay. Let me just write this down. So what you call it? 6.
6x
Yeah, and 3 wait, -3.
-3. Bring down the -7. Okay, so you got your distribute done.
And
Next
then
thing is to go ahead. Sorry.
do you next you go with the 6 -6 like on like the 6x and the 6x.
No, not yet. Not yet. You're
Uh,
one step ahead. Next thing is to combine like terms.
okay.
See how -3 and -7 go together?
Yeah.
What does that become?
Wait, like you add them together?
Yeah, I mean, you can think of it being a plus in here, -3 plus a -7.
Huh. Okay. Yeah, then just -10.
Good. So notice
But
on the left,
wait, so how do you like you always like just you pretty much find like anything you can do to just like make it smaller, right?
yes,
Okay.
like condensing or organizing.
Okay. And how do I know when to like add it?
It depends on the operators. So if they're both negative or one's positive and one's negative.
So if it was both positives, it would be subtracting, right?
Well, if it was like 3 plus 7, that's 10.
Yeah.
If it's -3 plus -7, that's -10. So when they're the same sign, see how these are both positive and both negative?
Yeah.
It keeps the sign.
Okay.
You can
Okay.
think of these as keeping the sign.
I got you.
The other one is a little more complicated. We'll address that if it comes up.
Okay, I
Um,
got you.
Okay. Now, this one is kind of like the last one, and this is where you move the 6x like you had just asked me about.
Yeah.
You subtract 6x from both sides. Okay, so that's -10 equals -10. Is this a true statement?
No.
So let me ask it differently. Is this an equality?
Yeah, it is.
Yes, that's
Yeah.
what I mean by a true statement. It is the
Okay.
same on the left as the right.
Yeah.
So
Okay.
when you get the same number, or when you get a number that equals the same number, this means the following. It means infinite solutions.
So do I write infinite solutions if I'm
Yes.
like on a quiz?
Yeah. Have you noticed in class what your instructor writes? Sometimes they write all solutions or
Yeah, yeah, there's like all solutions. Yeah.
okay, whatever they write, use that, even if it's, even if I don't agree with it, it doesn't, you go with what they want. I'm not
Okay.
grading you.
Yeah, gotcha.
Okay, now we are going to graph, and the line we're going to use to graph is this one right here. So let me know when you're got this down for us to move on.
Yeah, I'm ready. When you graph, would you just do the actually never mind.
So we're gonna do the same thing that we did before. We're gonna make two equations. The first one is y equals 6x minus 10. You're gonna tell me the slope and the b value.
Okay. So
Whenever
slope
you're
is
ready.
6 and b value is -10.
Good. And you can think of the slope as being really 6/1 as a
Okay.
fraction, so that it's rise over run.
Okay.
Now for the second one, it is the same equation, so it's the same slope and the same b value.
Okay.
I need to go up here and grab the graph. I will grab this. Okay, so now when we graph it, I'm going to do the first one over here in blue. So you start at -10, and then you go up 6. You literally count from that point. 1, 2, 3, 4, 5, 6. Right 1. 1, 2, 3, 4, 5, 6. Right 1. Sorry, that last dot's in the wrong place.
And you go
There it
right
is.
one every single time.
Yeah.
Okay. Cool.
1, 2, 3, 4, 5, 6. Really feel like I miscounted here, but okay. And so you get that line there. Maybe yours is better than mine, not sure. And then you graph the other one. Now you already know they're the same, but let's figure out what that means graphically. Well, you start at -10 again, and then you go, your slope is still 6/1. So you go up 6, right 1, up 6, right 1, up 6, right 1. So notice I've just covered up the dots, and then I graph an overlapping line.
Okay.
So the word you might use here is overlapping or same line. And
And
that's what
you could
mean.
kind of just assume that if it's the same, right? Because
Yes.
yeah.
Yes. You don't have to graph it twice. I
Yeah,
mean,
then
it's
could I just write up like same line or
yes.
something?
Yes.
Okay, cool.
And that means infinite solutions.
Okay, but
Okay, are you ready for the normal case, which I
yeah,
should have done first?
I could try to solve this one by myself. I'll try.
Sure. Yeah, go ahead and solve this algebraically and let me know what you come up with.
Okay. Okay, never mind. Actually, I do not know where to start.
Okay. You do know how to do this. We'll just step you through it a little bit here. So
Okay.
on the left side of the equation, you have an x plus x and a plus x.
Yeah,
What do those combine to?
the x and the x.
Yeah, you have 1x plus 1x. How many
Plus
x's is
2x.
that? 2x minus 1. Now on the right side, you have plus 2 and plus 3.
Yeah.
What do those combine to?
X1. Hold on, sorry, I'm still writing this.
Oh, sorry.
Okay.
Jumping a little bit ahead here.
Oh my gosh, dude, my pencil. Hold up, I'm sorry. Oh, my pencil broke. So it's 2x plus 3.
On the right side, we're just looking at the right side. Okay, maybe we need to redo the left side so you can see that it's 1x plus 1x. That's how you get the 2x, and then you just bring the minus 1 down.
Okay.
This minus 1 just gets brought down. Okay,
Okay.
these two combine into that 2x.
Okay.
Now on the
Okay.
right, what I'm trying to show you on the right is that there's a positive 2 and a positive 3.
Yeah.
What do those combine to?
5.
5. And then you just bring the minus x down.
Okay. And the minus x always goes on the right of the number, right? Or
Well,
the
you
x.
just bring whatever's down. Like if it was plus 7x, you would just bring it down.
Okay.
So all we're doing here is combining like terms.
Okay.
And you've done that, watch the video again if you're not sure. It'll make more sense the second time around.
Okay.
Okay, now in all the previous problems we've had, you've had like the same thing on both sides with x's. When you don't, the preference is to move from the right to the left.
Okay.
So what that means is you're going to add x to both sides. We're going to move the one from the right to the left.
Okay. So then you just are left over with 1x.
Well, you've got 2x plus 1x.
Well, like you,
On the right, they cancel.
yeah, that's what I'm saying. Like there's
Okay.
not 2x's now.
On the right, they're gone. On the left, there are now how many x's?
3x.
3x minus 1.
Yeah.
Okay, can you try solving it from here, getting it down to x?
Yeah. Do you do like negative? I don't really know.
Okay, so what is the math operation in front of the 1?
-1.
So the opposite, or not, sorry, how you undo subtraction is with addition.
Okay, yeah. Oh,
Addition is undone with subtraction. Subtraction is undone with addition. Multiplication is undone with division, and vice versa.
yeah. So 3x equals 6.
Okay. So how do you undo multiplication by 3?
Divide. Do you divide up 2 on each? Oh no, 3 by on each side.
Yeah,
Sorry.
the answer is 2. And yes, yeah, that is what
X equals 2,
what
and
you'll
then
do.
that's.
That's your answer.
Would you say all solutions for that?
No, this is like saying this is the only intersection.
Only solution then?
The only solution is 2. Yeah. But full disclosure, this is only half the answer. You'll see that in a moment when we graph it.
Yeah.
So let me know when you get all this down, and we'll
Yeah, I got it. I
do the
got it
graphing
down.
down. Okay, so for the graphing, I'm gonna grab this line right here. And I'm gonna get rid of that. Okay, and we're gonna do some graphing. So let me just move this down. Graphing. All right. So let's look at the right real quick. The right is going to be rewritten as minus x plus 5, or
Yeah.
you can think of it as minus 1x plus 5.
Yeah.
That will help us when we're graphing. So the first equation on the left here is 2x minus 1. I want you to tell me the slope and the b value, please.
The slope is 1, -1.
We're looking at this equation here.
Oh, sorry, 2.
2,
then
it's the number in front of
-1.
x, or you can think of it as 2/1 and the b is -1.
Yeah.
Now this one on the right, -1x plus 5. Same thing, I
Wait,
need the
why is
slope.
it? Wait, 2. Oh, yeah, sorry. Never mind.
The slope is the number in front of x.
Yeah. Oh, wait, what are you asking me?
I'm asking you for the slope and the b value of this
Oh,
equation.
the
on
slope is
right.
-1x.
The
And then
slope is
plus
only a
5.
number. It's just a number, just a
Okay.
number, never x, never x.
Okay.
And the b value,
5.
5. Now this is the first time our slope's been negative, but what this means is it's really -1/1.
Okay.
And we'll analyze that a little bit further in a moment here. So I'm just going to go back and grab the graph and snip it in here. Okay, we're going to graph the one on the left first. So you always start at the b value, which is -1.
Okay.
All right, and the slope is rise over run. So from that point, from that -1 that I graphed first along the y-axis, you're going
Yeah.
up 2 and right 1. Up 2 and right 1. Up 2 and right 1. And you can go backwards if you want, but get an idea here. So I'm gonna attempt here to draw as straight a line as I can. It's kind of average, but okay. Now for the one on the right, we're going to start at that b value of 5. B value of 5. Okay. Now it is always rise over run, but do you see how it's a negative up top?
Yeah.
The negative means instead of up, you're going down.
Okay.
So the negative means down 1, right 1.
Okay.
Down 1, right 1. So you from that 5, you go down 1, right 1. Down 1, right 1. Down 1, right 1. And so on.
Gotcha.
Now, if you do a really good job at graphing, you will find the intersection point.
Okay.
But the intersection point is an ordered pair. It is at 2. X is definitely 2. What is the y value there?
1. -1.
No, the y value. Y value. See how
Oh, 2 and 4 or 3.
4 is up 3. Yeah, so I know it's hard to see. So there's actually and it's a bit deceptive because there's actually 2 answers. There's an X and a Y
Oh, okay.
for that.